All right, so 7-2 is all elimination. I would say for your quiz and for your test, most of the time I will give you an option of what you want to use. We're going to stick to elimination today just to practice it. But most of the time when it's these, you'll get to choose. When it's graphing, it will be forced. So you'll get at least one in which you have to graph to find that solution. But the rest of them, you can kind of go back and forth between substitution and elimination. So for the goal, obviously, of elimination is to get something to cancel out. For number 1, if I just add, nothing cancels. But what's something you could do? Because there's more than one option here. But what's one attempt or one process you could do? Multiply the bottom by -3. I heard that one. And then the other option would be to change both if you want to cancel out the y's, right? So if I want to do the x, -3, here's -3x minus 9y. Be so careful because the biggest mistake people make with this is not going across the equal sign. Whatever you change to the others, you got to change the whole row. So then I'm going to bring this down and I get 3x minus 2y equals 7. I'm going to add these now. These cancel. I get -11y equals -11. Divide both sides by that -11 and y is 1. So that's the y coordinate of your solution. And then you want to take and plug them back in. You can plug them back into either. I'm going to grab this one. So x plus 3 times 1 equals 6. X plus 3 equals 6. Subtract the 3 and x equals 3. And again, these can get checked by just plugging those back in. So with extra time on any of the systems, you can always check by plugging them back in. Questions on that one? Okay, 2 gave decimals, but only in 1. You can get rid of the decimals just in 1. So I can multiply everything here by 10 to move my decimal each time. So it's 18x plus 12y equals 40. And then I want to, again, cancel. If I multiply the top by -2, I get -18x minus 12y equals -6. Add, and these both cancel. So I'd get 0 equals 34. Does 0 equal 34? No. So this is a no solution scenario. If I had put this on a graph, they would be parallel lines. They'd never intersect. Okay, then I gave you one with fractions. Okay, so again, you can make changes to each individual one. It doesn't have to be the same. I can multiply everything here by 8 and then coincidentally also 8 there, but they don't have to be the same. So 4 would go into 8 2 times. I'd get 6x, multiply this times 8, plus 8y equals, multiply this times 8, 1. Do the same for the bottom. 4 goes into 8 2 times. So I'd get 18x multiplied by 8 here plus 24y multiplied by 8 here, and they cancel. I get 3. Now I'm dealing with this system. I want to, again, change it so that it has the same for either the x or the y. So I can multiply this by like -3, God bless you, 18 minus 24y equals -3. These cancel, there's the 0 on the other side, but also 3 minus 3 would be 0. So this would be the all real numbers scenario. On WebAssign, it says infinitely many. You can write all real numbers. You can give me the ARN. You could give me the little fancy R. I don't care how you describe that if it's a quiz or a test, as long as you in some way show that that would be all real numbers. Questions on 1, 2, 3 before we move into the word problem? Okay, so then 4 says a grocer sells oranges for 95 cents each and grapefruits for $1.05 each. You purchase a mix of 16 oranges and grapefruits. You pay $15.90. How many of each type of fruit did you buy? So if we're setting up our variables, we can call the oranges X. You could call the grapefruit Y. You could have done O and G. It doesn't matter what you're going to do for your variables as long as you know which one's which. So what's one equation that you set up? X plus Y equals 16 because 16 total amount of fruit was bought, right? Other scenarios, because we've seen a lot of this, like it could also say there were 10 more oranges bought than grapefruit. You'd have to be able to set that up. Or twice as many grapefruit were bought as oranges. Like just be prepared for any kind of relationship to be set up between those two. It's not always going to be the total that they put together. Then, so that's the amount, right? Now we need the value. So each orange was 95 cents. And each grapefruit $1.05, and then the total amount was $15.90. So here's my system. I can because I have the calculator, I may leave the decimals and just multiply, but if you want to get rid of the decimals, you can. I would have to multiply this whole second line by 100 because I got to move it twice, twice, and twice. So 95x plus 105y equals 1590. And then my other equation is this. So if I'm doing elimination, because that's what we're practicing, I'm going to cancel out one of the variables. Make sure you read your question, because if your question said, how many grapefruit do you have and not how many of both, I would want to cancel out the oranges. It saves you an extra step. Does that make sense? If it had said, how many oranges did you buy, I would want to cancel out the grapefruit to save myself the extra step of having to plug it back in. Yeah. On the word problems, you can solve them any way you want. Yeah, I would just obviously not recommend graphing, but you could do substitution or elimination. Yeah, absolutely. So let's say I just want to get rid of the y, or the x. I'm going to multiply both of these by negative 95. So negative 95x minus 95y equals, and 16 times 95, negative 1520. I don't know if you can read that. No. So then I will change, or then I'm going to combine these. These cancel. I'd get positive 10y equals 70. Divide both sides by 10, and y equals 7. That's how many. Y was our grapefruits. So 7 grapefruits. And then if there's 16 total, 16 minus 7 tells you that there's 9 oranges. For this quiz, I'm going to let you use a scientific calculator. So if you have, like, you've been practicing with your graphing utility, that's fine, because there's times that you need the graphs, but on the quiz, you're not going to be able to use it, okay? So keep that in mind. There's no graph. So there's no y equals. Because then you would just type in all of the equations and get all of the answers. Yeah. Because you're not gonna. Questions on the warm-up before I do that? Oh, one question from the homework. We set this up yesterday, but we'll do it again, and then we'll solve it all the way through. This is the airplane flying into a headwind, travels 1,800 miles, flying distance from New York to Albuquerque. On the way there, it takes 3 hours and 45 minutes. On the way back, it takes the same distance. So we're doing 1,800 miles both directions, 3 hours and 36 minutes. So that's the faster one. Find the airspeed of the plane and the speed of the wind. So distance equals rate times time, and we need that for both of them. The difference is when you're accounting for wind speed or tailwind or headwind, like all different kinds of words go into that. That's affecting your rate. So if you're going against the headwind, which is what the first one is, it should slow you down, right? Like if you've ever been walking outside and you're going against the wind slows you down if it's coming at you, right? That would be like headwind. So if you're going, and this was from New York to New Mexico, that's when it's slower. The rate, we were going to subtract the wind from it because it's coming against it, which makes it slower. We're still going to multiply it times the time and still get the distance. Then from New Mexico to New York, now it's pushing from behind you as though somebody is like, giving you a little boost from behind. The distance would be the rate plus the wind times the t. For both of them, the distance traveled is 1,800. The R and the W are what we don't know. On the way there, the time is 3 hours and 45 minutes. So I have to convert this into hours. 45 over 60 is 3/4 or 0.75. So the time here is 3.75. On the way back, the time is 3 hours and 36 minutes. 36 over 60 is 1/6 or 0.6. So this would be 3.6. Now, whoever got the 30-minute, no, it was 20 minutes, so it was 1/3. If you rounded it, WebAssign marked you wrong, but it's okay. Like if you were doing this on a quiz, I would give you that you rounded it to like 0.3. WebAssign kept it exact as a fraction, so it kept it as 10/3. So if that's why you got it wrong, just realize that could be, like if you go back in now, you should see it. It could just be that wasn't rounded. So now I'm going to set up, here's my system. I have these two. So 1800 equals, I'm going to distribute this to both, 375R minus 375W. And then 1800 equals, and I'm going to distribute this to both, 3.6R plus 3.6W. Now we're practicing elimination, so I'm going to use that method. I would multiply the top by 3.6 and the bottom by 3.75. Happening. Okay, 1800 times 3.6 would be 6480. 3.75 times 3.6, 13.5R minus 13.5W. And then 3.75 times 1800, 6750 equals 13.5R plus 13.5W. When I add these are going to cancel. 6480 plus 6750 is 13,230, and then 27R. Divide there. And my rate is 490. This would be miles, right? That's what the unit says. Yeah, miles per hour. So that's without the wind. To find it with the wind, you got to plug it back in. You could plug it back into any of these. I could plug it here. I could plug it here, here, or here. It doesn't matter. Okay, so if let's say I take this one. Oh, this should be 1800 though. 1800 equals R, which is 490, minus, or plus W, times 3.6. I could take and plug it in here. That's this one. Here as well, like it'd be the same. 1800 equals 3.6 times R, which is 490, plus 3.6W. So 3.6 times 490, 1800 equals 1764, plus 3.6W, subtract the 1764. What is that, 26? And then divide 18. 36, not 26. Divide by 3.6. Decimal, decimal. Oh, 36. Yeah. And that's your wind speed. Okay, so you had different numbers, which obviously meant different, but the setup is the same for every single one of them. Only thing that changed was that time. They're going to be complicated. Like some of the word problems are going to give you complicated systems, but it's the same process over and over again. You've got to be able to solve it. And like I said, I'll let you use the scientific calculator. Vicky.
For the formula, the faster time is the one that you add rate.
Correct. Yeah, you're making your rate faster, so you add the wind. Okay, so 7-3. Okay, so 9 says on Saturday night, the manager of a shoe store evaluates the receipts of the week sales. 250 pairs of 2 different styles of running shoes were sold. So that's my first. X plus Y, 250. One sold for $78.50. The other $90.95. Totaling $20,870. Okay, so now I want to just multiply. Did you get rid of your decimals?
No.
Okay. Did you cancel out the X or the Y?
Yes, I multiplied by negative 78.5.
Okay, so negative 78.5X minus 78.5Y equals 250 times 78.5. Negative 19,625. Now I'm solving this system, right? So these cancel. 90.95 minus 78.5, 12.45Y equals 2870 minus 19,625. 1245. So you'd have to move that decimal twice. That's 100. That's the Y. And then they sum to 250. So I have to do 250 minus 100. 150 is the X.
Yeah, I multiplied
Oh, okay.
the 250. Thank you.
You're welcome. Okay. Okay, 3, solve the system, elimination. All right, so what did you do? Like, how'd you eliminate?
I multiplied by 3 and -5.
You got it, the negative.
Make it negative.
Okay. And then divide. V is 12/7. And then plug it back in. Okay. Is what we're going to start today. Like I said, I'm going to break it down over the course. I usually probably would do 2 days, but we're going to water this down for this week. We're going to baby step our way all the way in. We start with something pretty similar to what we're doing now at systems, but it's 3 variables, 3 equations. So this is like one of those processes that if you practice, you'll get the hang of it. You'll have done it a couple of times. It will be easy. It's just tedious, and you got to be careful because you're signs, because we make silly mistakes, okay? The second part of 7.3 is called partial fraction decomposition. That's what I'm leaving the video for tomorrow and Thursday. Is brand new, okay? And a lot different. There's some tie into it, but a lot different. So you just want to make sure if for some reason you're not here tomorrow or Thursday that you make sure that you watch those videos. Tomorrow's, I did the warm-up and that, so it's a little bit longer. Thursday's is short. Short and sweet, okay? But you got to make sure that you're paying attention. So we're on part 1 of 7.3, 3 variables, 3 equations. So we start this just like we did the last one, showing that every single solution here can be checked. So in order for a 3 variable solution to work, it would have to be plugged into each individual equation. The order is X, then Y, then Z. And I would literally just plug these in to see that this is or to show that is an answer. So X would be 1 minus 3 times 0 plus 2 equals 3. 1 minus 0 plus 2 and 3 equals 3. So that worked for that one. Then we go to the next one. 2 times 1 plus 0 minus 5 times 2 equals -8. 2 plus 0 minus 10 equals -8. And -8 equals -8. We're plugging in the X, the Y, and the Z. No, like the X we're replacing with the X it gives me, which is 1. The Y we replace the 0, and the Z is 2. And the third one here, 1 minus 0 plus 3 times 2 equals 7. This is gone. 1 plus 6 is 7. 7 equals 7. So just like last time, this is not like a test question. This is just showing you that they can all be checked. With extra time, you'd be able to plug those back in. Okay, so there are 2 types of problems in this section, well, in this part of the section with 3 variables. One is this, which is called a triangle system, okay? It is called a triangle system because the shape of actually what you're given is a triangle, okay? In these systems, and these are super easy, you just have to know what to do with them. In these systems, you have 1 equation with 3 variables, 1 equation with 2 variables, and 1 equation with 1 variable. So we work bottom up. We do something called back substitution. Which means I find the one that's already got an answer. And I plug it into the one that has 2 variables. And then I would find the second variable. And then I would take the 2 that I find and plug them into the top one to find the remaining one. So we're literally just working our way backwards up the ladder. So in a triangle system, there will always be 1 with 1 variable, 1 with 2, and 1 with 3. You just take them and plug them back. So if I look at this, and notice it says use this, I solve the system using back substitution. I'm going to take the Z and plug it in. So I'd get Y plus 2 times 8 equals 6. Y plus 16 equals 6. Subtract the 16. Y is -10. Then I take the y and the z, and I plug it back into the top one. Obviously, it's got to go in that one because that's the only other one that has x. Minus a negative 10 plus 5 times 8 equals 24. This becomes plus 2x plus 10 plus 40 equals 24. 2x plus 50 equals 24. Subtract the 50. 2x equals negative 26. Divide by 2. And x is negative 13. My answer goes x, then y, then z. So negative 13, negative 10, 8. Easy stuff, right? Just taking and plugging in. You just please be so careful with your signs. All right, this is what happens if all three equations have all three variables, okay? It's a lot of words. It sounds like a lot. I promise if you practice it, you'll be fine. But we are going to start by picking two of the three. It can be any two of the three equations. And we're going to cancel out a variable. And you can cancel out any of the three variables. So picking two, canceling out a variable. And then we're going to call it new one so that we just like know what to when we're talking about these things. That new one will only have two variables. Then I have to use the third equation I didn't use the first time because I got to pick. I only picked two. Whatever you didn't use, you have to use that one. You can combine it with any of the two you already used, but you have to cancel out the same variable. And we're going to call that new two. Now, if you've done it correctly, new one and new two have the same variables. If you didn't, then you haven't gotten rid of the variable you need to get rid of, right? So if I have x and y from new one, I have x and y from new two. If I did x and z, then I need x and z. Whatever two I have from one has to be the same as the other. Then we use new one and new two with elimination to cancel out the second variable. So this goes back to what we just did in yesterday's. We're going to have two equations with two variables. We narrow it down to one. And then we do that back substitution. We take the answer from the one, plug it into one of the new ones, and then take those two answers and plug it into one of the originals.
So new one and new two are going to be equations?
Yep. No, they're equations. And depending on what you pick and what a friend might pick, they could be different equations. So just because your new one and somebody else's new one are not the same doesn't mean you're wrong. They will always end up with the same system, like the same three answers at the end, but your process might be completely different. So in the end, again, you're getting an x, a y, a z. All right, I'm gonna number these so we know which one we're talking about. I'm just gonna call them 1, 2, 3. So we've got three equations with three variables. Here's where you want to go like 2 steps ahead of where you're at, because I'm going to have to pick two of these to cancel out a variable, but then I'm going to have to take the third with either of the other two and cancel out that same variable. So you want to kind of see a couple steps ahead, which was going to be the easiest. So pick two equations in which it's easy to cancel out any of the variables. Okay, so if I pick 1 and 2, what variable are you going to cancel out? Y? Is that what you said? Oh. You could do y? Okay. So if I do that, right, so that's my first plan. The second time around, I have to use 3. Is there not with the new one. I have to use it with one of the ones, the other two. The 30, well, this time it's the one we didn't pick, which also is number 3, but it doesn't have to be that way, right? I have to cancel out the same variable. So is it going to be easy to cancel out the y from this with another one? Which one would you pick? Pick these two, not x, it would be 1, 2, 3, right? And then also cancel out the y. I'm going to say that all over again. You've got to plan ahead. You've got to plan ahead because sometimes it might be easy. Like let's just say I do this. If I were to pick 1 and 2 and cancel z out, okay, I would have to then pick 3 and still cancel z out. So you want to make sure it's going to be easy to do that variable twice. Does that make sense?
So if you were to do that, you would probably
Correct.
Because
You don't want to have to change both. Yes. You're not always going to have that option, but if you do, for the most part you do, certainly choose it if you can only change one, okay? If I had picked 1 and 2 from the beginning, and let's say I was going to cancel out the x, I could do that, right? 1 and 3, sorry. I could multiply 1 by 2 to cancel out the x. Do we see that? But then the second time around, I have to pick 2, and I have to cancel the x. So I would do like 2 and 3 multiplied by 4, or I could do 2 with 1 and multiply by -2. Do you understand? Okay, so you kind of want to, you could go in blindly. You just might get messy. It's going to work still as long as you're careful. But I would recommend planning ahead. All right, so we are going to pick 1 and 2, and we are going to cancel out the y. That was our first plan. So in order to do that, I have to change what? I have to multiply the first one by 2. So I'm going to get 4x, I'm going to multiply here, I'm going to multiply here, plus 2y plus 6z equals 18. Make sure you go across the equal sign. Then I'm going to take 2, and I don't need to change anything. It's already going to cancel. X minus 2y plus z equals 8. And we are going to combine these. So 4x plus x is 5x. Positive 2y, negative 2y cancel out. That was our plan. 6z plus z is 7z. And then 18 plus 8 is 26. And we're going to call this new 1. Just so we give it a name. Now I have to use the third equation because I haven't used it yet. And I have to cancel the same variable. So which one did we say was going to be easy to combine with 3, 1 or 2? 1, and we're going to do what to 1? Good. Multiply by -3. So I'm going to do -3. I'm going to rewrite it down here. Times 2 to cancel it with 3. If you need to do that in separate steps, do it. Like rewrite these out and then say, how would I cancel out the y? I'd multiply by -3. So now I'm going to do that.
Why would it be -6x?
The x is not working. We're trying to cancel the y.
Yeah, but 2 times
I just rewrote it. I'm going to now distribute it. I shouldn't want to do that in one step. That's where I lose people. Yeah. So this would be -6x minus 3y minus 9z equals -27. And then -4x plus 3y plus 2z equals -4. This is -10x. The y's cancel, which was our goal. Minus 7z equals -31. And this is new 2. On a new 2 and solve that system. So 5x plus 7z equals 26 and -10x minus 7z equals -31. I would obviously recommend elimination here. I'm not going to tell you to do substitution. You can if you really like it, but it's not going to be as easy.
Is it always, are you one and you always going to cancel?
No, great question. No, we got completely lucky that they're 7 and -7. If at this point they didn't, then I would change them. I would solve using elimination just like we've been doing. So right now, if I add these, they do cancel. I get -5x, 7y and -7y cancel, equals -5. Divide both sides by -5, and I get x equals 1. There's the first of my 3-part answer. Now, where do I go with that? Plug it back in. Can I plug it back into the originals? No, why not?
You have to plug it into one of the ones
Because it has 2. If I plug it back into the original, there's still 2 unknowns, right? There's 3 variables there. I only know 1. It doesn't matter which of these 2 you pick. So if I just wanted to grab the top one, 5 times 1 plus 7 times z equals 26. 5 plus 7z equals 26. 7z would equal 21, and z would equal 3. Now I have 2 of my 3 variables, and I have to plug that back into where? Any of the original ones, but it has to be an original one, otherwise there's not all the variables. So I'm going to grab this middle one. X minus 2y plus z equals 8. X is 1. 2y plus z is 3 equals 8. Negative 2y plus 4 equals 8. Negative 2y equals 4. And y equals negative 2. And then my answer goes in order: x, then y, then z. Yeah. After I stay there for her, I'll move back into there. Yeah, okay. All right, we're gonna number them again. 1, 2, 3, just so that we have names to call them. Okay, pick two equations. Well, look at all the variables. That's what I would say first. Look down the lines and see which one's gonna be easiest to cancel out. Sometimes they're about the same. What do we want to cancel? You want to do 1 and 3, is that what you said? 1 and 2 to cancel out what? X. Okay, so we're going to multiply 1 by negative 2. And then you have to use 3. And what are you going to use 3 with? Good. That's what I wouldn't, because you don't want to do 3 and 2 after you've done. Does that make sense? Then you have to change them both.
You said 3 and 1.
She said 1 and 3. No, she said 1 and 2 to cancel out the X. That's the plan, right? So then you have to use 3. I don't want to combine 3 with 2 to cancel out the X, because then I have to change both. So I'm going to do 3 with 1. So we're going to do, that's because once you do 1 and 2 and you cancel out the X, you have to use 3. And I have to cancel out the X. So I don't want to use 3 with 2 to cancel out an X, because then I have to multiply them both by something. If I do 3 with 1, I only have to change the 1. No. We just canceled out the y first last time. You cancel out whatever's easiest. All right, so our plan is 1 and 2 to cancel out the x. So I have 1 and I have 2. I'm going to write this over here just so that we see it. 1 and 2, and then I want to cancel out the x. So last time I did this in one step, but I'm going to separate it out so you can see it. I want to cancel out the x. I'm going to multiply 1 by negative 2. Negative 2x minus 2y minus 6z equals negative 14. And then I'm using these two. Cancels out the x. That was our plan. Negative 6y minus 5z equals negative 7. And this is new 1. I have to use 3 because I didn't use 3 the first time, and I have to cancel x. So I'm going to use 3 with 1 because it's going to be easier to cancel the x from 3 and 1 than it is 3 and 2. So I'm going to do 3 and 1. And I have to cancel the x. So I'm going to multiply the bottom by negative 3. Negative 3x minus 3y minus 9z equals negative 27. And I'm adding that to the first one. So I'm doing these two.
It would be negative 21, right?
Yeah, well, wait, where?
For 3 times 7.
Oh, would I write 7? Yes, thank you.
So the second time around when you're making U2, you get the one you have used and one you have.
And then one you have, either of the ones you have, and have to cancel the same variable.
So when you grab when we use the equation from 1, you can use the original one, right? Not the one that was.
Correct. You want to use the original one.
Not the one that was multiplied by negative.
Right, because that only changed it for that one.
Oh, okay.
Yeah.
So you can, like, multiply.
Yeah.
if you need to.
As long as you multiply the whole equation by whatever you want to multiply by, you could multiply it times anything you want except for 0. Like, you can't cancel everything out, but you can multiply it times anything.
We said we were solving for everything.
We're canceling out x. Because we did it here, right? We canceled out the x there. So now I get 2y minus 13z equals negative 27. And that is new 2. Now I take new 1 and new 2. And we did not get as lucky this time because nothing just cancels, right? I can cancel either variable though, so which one's going to be easier to cancel? Good. I'm going to multiply the y by 3. So I'm going to get 6y minus 39z equals, did I do that right? 81, yeah. And then I'm going to bring down the first one. My y's cancel. Negative 44z equals negative 88. Divide both sides by negative 44. And z equals 2. Now what do I do when I get the first variable solved? Plug it back into new 1 or new 2. Doesn't matter which one. So let's just say I grab new 1. Negative 6y minus 5 times 2, which is the z I just found, equals negative 7. Negative 6y minus 10 equals negative 7. Add the 10. Negative 6y equals 3. Divide both sides by negative 6. I'm plugging it into one of the new ones. And I get y is negative 1/2. And then what do I have to do from here? Plug it back into the one of the original ones. Doesn't matter which one. I'm going to grab the top one because it has the least amount of coefficients, but it doesn't matter. X plus y, which would be negative 1/2, plus 3 times 2 equals 7. X minus 1/2 plus 6 equals 7. I can keep my fraction, or I can multiply everything by 2 to get rid of it. 2x minus 1 plus 12 equals 14. It's still going to come back at the end, but it's fine for the time being. 2x would equal 3. Oh, that's so hard to read, sorry. And x would equal 3/2. So my solution set is 3/2, which is the x, negative 1/2, which is the y, and the z, which was 2. God bless you. You can see special cases with this just like everything else. If your variables cancel out and it's a false statement, it's still no solution. If your variables cancel out and it is 0 equals 0, then it's all real numbers. So the same special cases can happen with 3 variable equations as can happen with 2 variable. I will just say this to you, you better show all the work. There's a lot of work on these, okay? There's not a lot of questions in the homework, but there's a lot of work for each one. And also realize that because the way WebAssign works, you might get bigger numbers than somebody else, okay? If they're like ridiculous numbers, feel free to use your scientific calculator. Like, I don't care. Just be really, really careful, okay, when you're setting them up, because one little negative along the way and you're going to get super frustrated. So that's one of those go slow to go fast scenarios.